5 multiplied by 5 is written as 5 to the power of 2, or 5 squared. The reason it's called 5 squared is because 5 squared is the area of a square with side 5. So the area of this square is 5 times 5. 5 multiplied by 5 multiplied by 5 is written 5 to the power of 3, or 5 cubed. The reason it's called 5 cubed is that 5 cubed is the volume of a cube whose sides are 5. So we have 3 dimensions here. Length, if you like, height by length by breadth. Of course, we can imagine higher dimensions. We could imagine a 4-dimensional object whose sides are 5. So the volume of that object would be 5 to the power of 4. Obviously we can't imagine such an object. Now suppose we want to multiply 5 squared by 5 cubed. Well, 5 squared is 5 times 5. 5 cubed is 5 times 5 times 5. So how many 5s have we got altogether? We have 1, 2, 3, 4, 5. So we've 5 5s multiplied together. That's 5 to the power of 5. So that brings us to one of the rules for powers. And that is when the base numbers are the same. These numbers are called the base numbers. We just add the powers. So 5 to the power of 2 times 5 to the power of 3 is 5 to the power of 2 plus 3. 2 plus 3 is 5. Of course, the base number doesn't have to be a number that we know. It could be some unknown quantity that we can call x. If we want to multiply x squared by x cubed, x squared means x times x. X cubed means x times x times x. So we have 5 x's altogether, or x to the power of 5. So in general, if we have x to the power of some number m multiplied by x to the power of a different number n, then the result will be x to the power of m plus n. By the way, x by itself can be referred to as x to the power of 1. So we can add all these powers. 1 plus 1 plus 1 plus 1 plus 1 is indeed 5. Perhaps to see more clearly why x to the power of 1 is x, we could consider this multiplication. X squared multiplied by x. Well, we know that x squared is x times x, and then we multiply by x, another x. So we have 3 x's here. So we know that our answer is x to the power of 3. So that tells us that this power is 1, because 2 plus 1 gives us 3. So x by itself means x to the power of 1. The next thing I want to do is consider the meaning of x to the power of 0. X is any number. Suppose we have x squared and we decided to multiply it by x to the power of 0. And let's suppose that the result follows this rule up here. X to the power of any number m times x to the power of any other number n, or the same number, is x to the power of m plus n. So if we follow this rule, if this rule is obeyed by x to the power of 0, we should get x to the power of 2 plus 0. But 2 plus 0 is 2. So we should find that x squared times x to the power of 0 equals x squared. So that tells us that x to the power of 0 is just x squared divided by x squared. We take this x squared and we divide by x squared and we get 1. Of course, I could have done this for any power of x. I could have used x to the power of m times x to the power of 0 equals x to the power of m plus 0, which is m, which tells us that x to the power of 0 equals 1. So this is a very important fact. Any number to the power of 0 is 1. Now we've talked about multiplication. In the next section I will talk about division. And I can also show you how this arises, why x to the power of 0 equals 1. So I can give you a second reason for this. Let's suppose we want to take x to the power of 5 and divide it by x to the power of 2. You can see that these base numbers are the same. Well, we can write it like this: x to the power of 5 over x to the power of 2. X to the power of 5 means x multiplied out, so that we have 5 x's. X to the power of 2 means x times x. Now, since everything is multiplied on top and multiplied underneath, we can cancel these out. And you see, we just have 1 times 1, which is 1 times x times x times x. Well, that's x to the power of 3 divided by 1 times 1. X to the power of 3 over 1, or just x to the power of 3. So you can see what's going on here. We take this power here and subtract this power to get our new power. So we see that x to the power of 5 divided by x to the power of 2 is x to the power of 5 minus 2. And 5 minus 2 is 3. So that brings us to our second rule. X to the power of m divided by x to the power of n equals x to the power of m minus n. And it turns out it doesn't matter what these numbers are. They could be natural numbers, negative integers, they could even be fractions. And I'll explain about fractional powers later. Let's consider this problem. X to the power of 3 divided by x to the power of 3. Well, we know that that's just x times x times x divided by x times x times x. We can cancel all of these out, so we get 1 over 1, which is 1. Or we can just do the division here. X cubed divided by itself is 1. But we can also use our rule. X to the power of 3 divided by x to the power of 3 is x to the power of this number minus this number. 3 minus 3. But 3 minus 3 is 0. So again, we can show that x to the power of 0 must equal 1 by considering this division rule. And of course, x can be any number. 2 to the power of 0 is 1, 7 to the power of 0 is 1, minus 10 to the power of 0 is 1. The only problem is 0 to the power of 0, but we needn't worry about that. You won't see that. Now what happens if the power on top is less than the power underneath? So m is less than n. So we have x cubed divided by x to the power of 4. Well, we can cancel these off, so we just have 1 over 1 times x. So we just get 1 over x. But of course, if we apply our rule, we know that this must equal x to the power of 3 minus 4. So we're assuming that this rule works for any numbers m and n, even if m is less than n. So we take the power on top and subtract the power underneath. But 3 minus 4 is minus 1. So we get x to the power of minus 1. So we're assuming that this is possible, that a negative power somehow makes sense. And, you know, we're following this rule for any numbers m and n, and it leads us to this conclusion, that 1 over x is x to the power of minus 1. Notice that x is just x to the power of 1. So we will see that these numbers have opposite signs. So if this number is a 2, then we will have x to the power of minus 2. So here's an example that will lead to 1 over x squared. X to the power of 5 is x times x times x times x times x divided by x cubed. And we're left with just x times x, which is x squared. Actually, this one is not a problem. What I should have done is put x to the power of 3 over x to the power of 5. Here it is, x to the power of 3 over x to the power of 5 is x times x times x over, we have 5 x's here, we can cancel a lot of these, so we just get 1 on top, and we have 1 times x, so we get x squared underneath. But if we use the rule, that's x to the power of 3 minus 5. We take the power on top and subtract the power underneath. 3 minus 5 is minus 2. So here we see that 1 over x squared is x to the power of minus 2. So in general then, we can say that x to the power of minus m is 1 over x to the power of plus m. So this is a very important rule. We can also see that this rule ties in with what we did earlier. Suppose I multiply both sides of this equation by x to the power of m. So I get x to the power of minus m multiplied by x to the power of m equals this thing here, 1 over x to the power of m multiplied by x to the power of m. So all I've done is multiply both sides by x to the power of m. Now, we can now use our rules. X to the power of minus m times x to the power of plus m is x to the power of minus m plus m. When we're multiplying, we add the powers, provided that our base numbers are the same. They're both x's. So we take minus m and add m. Now, what do we get when we multiply 1 over x to the power of m times x to the power of m? Well, that's just x to the power of m divided by x to the power of m. We have x to the power of m times 1 over x to the power of m times 1. You can think of a 1 here. We just multiply across the top and multiply across underneath. But x to the power of m divided by itself is 1. So you see that we get 1 here. But look at this thing here. X to the power of minus m plus m. That's just x to the power of 0. So we end up getting back this important result. So it all makes sense. In order to explain fractional powers, I want to take a simple example. We know that 5 multiplied by 5 equals 25. Suppose we want to write 5 as a power of 25. Suppose we want to write 5 as 25 to the power of some number. I'll call that number x. And of course this is going to be the same. It's going to be 25 to the power of x. And on the right hand side we have 25 by itself, which means 25 to the power of 1. Now let's apply our rules for multiplication. We see that we have the same base number here, and that means that we can add the powers. So we get 25 to the power of x plus x, but x plus x is 2x. So that's the left hand side, and on the right hand side we have 25 to the power of 1. So now we can actually find out what x is. We have the same base number on each side. If we have the same base number, we must have that the powers are equal. So we have to get a single term on each side. We can't just do equating here. We have to multiply these two terms together to get a single term before we can equate the powers. Now this is an important idea. We'll be doing some exam questions soon where we will be doing this kind of thing. But I just want to show you how a fractional power can arise from this situation. So we're assuming that the laws for multiplying hold. When we multiply two terms, we add the powers, provided the bases are the same. Anyway, we get to this. The only way that these two terms can equal each other is if the powers equal each other. 2x must equal 1. But if 2x equals 1, it means that x must equal a half. So, what have we found? Well, we found that 25 to the power of x, which is a half, multiplied by 25 to the power of a half, equals 25 to the power of 1. So now we found a meaning for this power. It means get the square root of 25. The square root of 25 is 5. So when we put a number to the power of a half, we get the square root of that number. The square root of 25 is 5, and we'll have 5 times 5 indeed giving us 25. We can also work out what the meaning of raising a number to the power of 1/3 is. If we take 5 multiplied by 5 multiplied by 5, which is 125, we can write 5 as 125 to the power of 1/3. So when we multiply these together, we just add the powers. A third plus a third plus a third is 1. So you can see that this thing here must mean the cubed root of 125. So in general, x to the power of 1 over m is the mth root of x. So if m is 4, x to the power of 1 over 4 is the 4th root of x. If m is 5, x to the power of 1 over 5 is the 5th root of x. I've written out x to the power of 1 over m multiplied out by itself m times. So we have m terms here. And we use the rule for multiplication. We just add all the powers. So we have 1 over m plus 1 over m plus 1 over m. But it's m 1 over m's. M times 1 over m is m over m. But m over m is 1. So you can see that this thing here must be the mth root. If we take the mth root of x and multiply it out m times, we just get x. Now if that doesn't make much sense, I wouldn't worry about it. The next thing I want to discuss is how to deal with brackets. So we have something raised to a power and a whole lot of it is raised to another power. So let's see what this means. We have 5 squared cubed, so that means 5 squared times 5 squared times 5 squared. So we write out 5 squared 3 times because this power is 3. Now we can use our rule for multiplication. The base numbers are the same. These numbers are 5s, they're all the same. So we just add the powers. So we get 5 to the power of 2 plus 2 plus 2, which is 6. So you can see the rule. We just multiply 3 by 2 and we get 6. So in general, if we take any number x, raise it to the power of m, and raise the whole lot to the power of n, that's the same thing as x to the power of m times n. We multiply m by n. In the next video, I will look at some exam questions.